So this is topic 5C, part 1, change of state and internal energy for the iGCSE syllabus. So what have we got here? So we've got some special units. So we've already talked about pascals. So we're looking at 1 Newton per meter squared is 1 Pascal. You should be familiar with that. We've got the Kelvin scale. So it's a temperature scale based on the motion of particles. So minus 273 degrees C is 0 Kelvin. It's much more useful to physics than just having the standard 0 to 100 Celsius scale, which is based on the boiling point of water and the melting point of water. So this one is when all the particles will stop moving. So then we can actually make our graphs make a little bit more sense. So you've got to start thinking about this and be careful in calculations. You should be able to understand the difference between a solid, a liquid, a gas, their change of state ideas, so melting, freezing, sublimation, condensation, boiling. Be able to explain what happens in condensing and freezing, so gas to liquid, particles get closer, they stay random, they start moving quickly in all directions, can only move around each other. That would be making a solid or making a gas, and it is the idea of the particles changing. So liquid to solid stay close together, random to regular stop moving around each other and only vibrate on a spot. So it depends on which way you're going with what's happening. You've got to be able to explain it. Specifically, you should be able to talk about the change of state graphs. So you're looking at how things are melting and heating up and the particles move faster. So this example graph would be, so B to C, particles move faster as temperature increases, the kinetic energy store goes up. Whereas this sort of part, where it's A to B, or it could be C and further on, this one in this case is going from a solid to a liquid. And the temperature's steady. So the difference is the thermal energy store goes into breaking the bonds between the molecules. When that happens, there is an increase in our internal energy without increasing the temperature. So it's a difference really between potential energy and bonding changes to kinetic energy, where the actual temperature goes up. You've got to be able to explain it. Got to be able to talk about condensation evaporation. So condensation, when the particles don't have enough energy to remain as separate particles, so they coalesce, they condense, they come together. That's if a gas is cooled down. Evaporation, though, particles in a liquid will always have different energies. So some are fast, some are medium, and some are quite slow. And so what happens is if we have evaporation, the really fast particles leave, and they leave what's left with a lower average kinetic energy store. So some of the energy is leaving. Of course, it increases if the temperature of the liquids increase. So the temperature difference between the liquid and the outside is more, then the gradient is steeper. And if the surface of the liquid is increased, so you could be taking a cup of tea, dropping it all over the desk, of course we get more evaporation. And if air moves over the surface of the liquid as well, that will take some of the particles with it. So you should be familiar with evaporation, like I said, and condensation. So there is change of state, iGCSE physics.